Hello, and welcome back to the second speedrun of today. So we're going to be continuing with our exploration of function transformations, and this time we're going to be looking at the reciprocal of a function. So let's jump right in. So to graph the reciprocal of a function, we need to remember a lot of important rules. So first of all, the zeros of f of x, so whenever f of x equals 0, will be the vertical asymptotes of our new function of 1 over y. Because 1 over 0, it will tend to it but never reach it. There's a lot. I'm going to zoom out. Okay. So the second thing we need to remember is that if whatever the y-intercept is of f of x, so say the y-intercept is called b, then for 1 over y, the y-intercept will be 1 over b. Next, the minimum values of y of f of x will have the same x values as the maximum values of 1 over y. So actually, it should be the minimum values of y will have the same x values as the maximum values of 1 over y and vice versa. Notice that we're only getting the reciprocal, not the negative reciprocal. So whenever y is greater than 0, 1 over y is also greater than 0 and vice versa. And finally, when y approaches 0, 1 over y will approach infinity. So that's all we need to know, but let's illustrate some of these rules by graphing a simple equation. Y equals f of x. We need to graph the reciprocal, and I mean, you probably already know the reciprocal, but let's use some of these basic rules to break down what the reciprocal will look like. So, first of all, we know that it intersects at 0 at this point, and so therefore this will be a vertical asymptote on the graph 1 over y. Y equals 1 over x. So y equals 1 over x will tend to this line, but never touch it. When y is positive, as you can see in the first quadrant over here, 1 over y will also be positive, and when y is negative, 1 over y will also be negative. So we don't expect to see 1 over y in any of these areas. When, of course, sorry, I should write that y equals x. And when y approaches 0, 1 over y will approach infinity. So as you can see here, we're approaching 0, and so we will be approaching infinity, or negative infinity. And so what does the graph look like? Well, it will look like this. Y equals 1 over x looks like this. Because, yeah, for all those rules that we have over here. That's pretty much it. I hope that you understand this explanation, and so let's go into some questions to clarify any doubts. So I'm going to be doing even questions for this one because we did odd ones last time. And for the first set of questions, all we need to do is we need to sketch for y is equal to f of x. Sketch y is equal to 1 over f of x. Labeling all intercepts, asymptotes, and any maximum or minimum points. Okay. Pretty good. And for the even questions, we have first y is equal to 1 minus 4x. So, y is equal to 1 minus 4x. Well, what does the graph of that look like? It will look something like this. So, first, what do we see? We see a 0, so we know that this will be a vertical asymptote of its reciprocal. We see that below this point, y equals 1 over minus 4x is negative, and above this point, y equals 1 minus 4x is positive. And as it approaches 0, it should tend away. So, using all of that information, sorry, I should write it out, that the asymptote would be 1 over 4, because the asymptote occurs, of course, when x equals 0, when y equals 0 and y equals 0, in this case, but x equals 1/4. So what does the correct graph look like? Well, it should look something like this, simply. And that is it. This is y is equal to 1 over 1 minus 4x. Yeah. Oh, we should label the intercept. That's the last thing we should label. And this intercept is technically wrong that I've drawn. So let's backtrack a little and find out what the intercept should be. So the y-intercept of this normal equation is 1. Actually, no, then I drew it correctly. Because remember, the y-intercept of 1 over y should be 1 over what the original y-intercept is. And since the original y-intercept is 1, the new y-intercept will still be 1. So this is correct. And the graph should look something like that. Okay, this is y is equal to 1 over 1 minus 4x. Done. Okay, next question. We have y is equal to x times 2 minus x. What does this graph look like? Well, we know for the default graph, this will be, of course, 2x minus x squared. So we have a y-intercept of 0 and an offset of 2x, and we have x squared. So I believe it should look something like this. Yeah. Oh, sorry. No. I've got it wrong because it's negative. Of course, we're doing it the other way around. So should, of course, attempt 2, attempt 3. There we go. Got it through like that. Because we know the roots of this equation will be 2, 0, and of course 0, 0. Since we have x is 2 minus x, so when x is 2, y will be 0. And so we know these must be the two asymptotes of 1 over this equation. Oh. Yep. So this is x equals 2, and x is equal to 0. What else we know? We know that there's a minimum point over here, and we can find that minimum point by rearranging this into vertex form. This would be negative, assuming you haven't done calculus yet, this would be negative x minus 1 squared plus 1. So this minimum would be at 1, 1. Sorry, this maximum. What am I talking about? Minimum. This maximum would be at 1, 1. So the minimum of the local minimum, at least, of 1 over x times 2 minus x would be at this point. Knowing all of this, we can now sketch the graph. It's negative in this area, and it will tend to infinity over here. It does not have a y-intercept since x equals 0 is an asymptote. Should actually have the same minimum as our other graph, and it should look something like this. So this green graph corresponds to the graph of the reciprocal. Okay, and moving on to the final question of this challenge, we need to copy the graph and sketch the graph of the reciprocal. And the graph we're given is a graph that looks like this. So first we go up, then we go down, then we go up, and then we go down. And we need to graph the reciprocal. Okay, so what do we know? We know that we have 4 x-intercepts, and so all 4 of these will be asymptotes on the new graph. So we can have an asymptote there, an asymptote there, an asymptote there, and an asymptote here. Oh. You know what? I'm going to start using the ruler. If I can get it to work, of course. Oh, of course, it's a scroll. Okay, here, so we can graph an asymptote here, we can graph an asymptote here, we can graph an asymptote here, and we can graph an asymptote here. Okay? And so now we can look at what the reciprocal of this graph would look like. So we know there's a maximum here, so there must be a minimum somewhere here, same as there, and same as here. We also, I mean, is that all we need to know? I think that might be all we need to know. Yeah, I think so. And so our new graph will look, well, it's negative over here, so we have some negative parts, and then we have some positive parts, and then we have some negative parts, and then we have some positive parts, and then we have, again, some negative parts. Not as abrupt as that. Probably be a more gradual change. Okay, and yeah, that's it. So that's how you would graph the reciprocal of a function. I hope you enjoyed this speedrun, and I hope to catch you in the next one. See you then.